Hi everybody, I am Dr. Vivekananda, Assistant Professor, Department of Mathematics. Today I am going to give a lecture on real life applications of differential calculus. Means how derivatives shape our daily world things that we are going to discuss now. Okay, so these are the AI images which gives the applications of derivatives behind these images and how means first image is about a roller coaster which works on curves and slopes. How how we design the curves and slopes so that the roller coaster works properly. So behind roller coaster works properly, there is a concept of curve curvilinear and slopes. Those are the main roles play here to work roller coaster properly. And the next image is about city skyline. This city skyline looks beautifully and comfortably to live to live pleasantly, which in which the background helps us the slope and curviness of the construction along the city over the city. That is what derivatives plays a vital role in our life scenarios. Okay, now let us learn what is let us know about differential calculus. What is differential calculus? So it studies state of change, how the changes happens in surroundings. That will also help us with a derivative. That is we represent by the tool dy by dx. And the geometric mean of a differential calculus is slope of a tangent line, right? And real life meaning. So what is real life meaning of a differential calculus is how fast something changes at an instant that we come across in our in all surrounding in our surroundings. Example: speedometer in a car shows derivative of position with respect to time. Speedometer in our car, it is change on with respect to the movement of the car. Okay, that is what activity change of rate of change. And the curve I have provided here, the curve I have provided here, which gives a slope. This is a curve. So for this, the curve changes from left hand side to right hand side. The rate of change will be evaluated. The rate of change can be evaluated with the slope, right? Next, in physics, motion, application of motion. A ball thrown upward, what happens? It reaches some height. The height function I am just writing by height function I am taking by minus 5t square and plus 20t plus 2, where t, the variable t, is said to be a time. Okay, so this is the height function we defined with respect to the scenarios at ball thrown. So now derivative of this function is h dash of t, which is going to be minus 5t square, minus 5 into t square differentiation is 2t, t square differentiation is 2t, plus 20 t differentiation is going to be 1. So into 1 plus 2 differentiation is going to be 0. So which is equals to minus 10t plus 20. This is h dash of t derivative. So derivative of height function is like velocity. Means height function is nothing but a displacement function. When ball thrown upwards, it moves upwards is like a displacement. So height function is nothing but a displacement function. So the displacement, the rate of change of displacement, what we learned as the velocity, na? So that we represent by v of t. H dash of t is a derivative of height function, which we which we represent by v of t is equals to minus 10t plus 20. Again, second derivative of h of t. Second derivative of h of t is nothing but first derivative of v of t. It gives acceleration. Gives acceleration. Okay. So first derivative of h of t is gives velocity, and second derivative of h of t is nothing but first derivative of velocity gives as acceleration. Okay. So second derivative of h of t is going to be 10, is going to be minus 10, because minus 10t plus 20 is again differentiation of h of t, then is going to be minus 10. This is the acceleration meters per square, as we had in constant values. So I'm taking as meters per square. Say velocity is meters per second, like. Okay. So these in physics, the motion we evaluated using the we define the function, and accordingly we evaluate velocity and acceleration. So this is the figure I provided, which gives, sir,
ఏమైంది సార్?
ఇక్కడ నా వీడియో రావట్లేదు, అవసరం లేదా?
వస్తున్నాడు సార్ అది.
Okay.
కంటిన్యూ సార్.
So here real use, what are the real life uses? Designing vehicle suspensions. Vehicle suspensions when we on driving a car or vehicles in roughy roads, means in a roads which are not in good conditions, good in ways. In such you require, the vehicles require suspension. That suspension technology is developed using derivatives. And predicting projectile landing points, means where actually when you throw a object, where the object actually fall, where the object fall, that point we can predict it. And that is what in nowadays wars and all, means projecting bombs in wars, projecting bombs by locating a fixed point, is a concept behind that, a concept of a derivative. Next, rocket trajectory planning, where actually land, that planning will be held by using the concept of derivative. Okay, so this is what a projectile motion, projectile, when we fire the bombs, how where the exact target we reach. So the target point we reach, that will be predicted by using the concept of derivative. Next application, finding maximum height. So previously we got a function h of t, and whose derivative is h dash of t. And if you want to evaluate maximum height, so then first derivative equal to 0. So from that we are finding t value. So t is about the time. So at time 2 seconds, the means the ball, the thing will reach us to maximum height. This is maximum height. Of course, these t values are not plotted correctly, means these t values are distributed on a x-axis. So at t is equal to 2, it reaches to maximum height, that is 22 meters. Okay, so here finding peak of roller coaster. Okay, so we can find the peakness of the roller coaster, and optimal launch angle fireworks, when bombs are fired or a rocket launched. So the optimal launch, we can find it. Okay, so this is what second application of derivative. Third Third application in business and economics. In business and economics here. Marginal analysis. Marginal analysis. See, company's function, company's cost function is designed like this. Like this, where x is nothing but number of items. This design function with respect to their operational systems, and inputs and all involved in construction of this function. So marginal, this is the company's cost function, and the marginal cost function is evaluated the first derivative of cost function, company's cost function. That is 500 differentiation is going to 5000 differentiation is going to be 0, 200x differentiation is going to be 200, minus 0.05 x square differentiation is going to be 0.10x. So this is first derivative. So this represents marginal cost. Marginal cost means cost to produce one additional item. This is the meaning of marginal cost. Cost to produce one additional item. And revenue function. Revenue function overall. What is the revenue we come across on production? That defined by the company by 300x minus 0.1x square, which is formulated by the company. Okay, so from this we need to define marginal revenue. Marginal revenue is nothing but rate of change in the revenue function, that is odd as of x. So profit maximization, when we maximize the profit function means, so here marginal revenue equals to marginal function, marginal cost, then we attain maximum function. So here marginal revenue and marginal cost are evaluated using derivative concept. Next, business example like maximizing profit. So this is the function defined. Profit function is defined like this, which is built by the company or some manufacturer with respect to his criteria. So to find the optimal production, he has to differentiate a profit function. So by differentiating p of x, you will get p dash of x, that is minus 2x square differentiation is going to be minus 4x, and 1000x is going to be 1000, and minus 1000 differentiation is going to be 0. So minus 4x plus 1000 is the derivative of p of x. So if you equate first derivative function equal to 0, then you will get x. So x is equal to 250 units. Here x is nothing but number of items that manufacturer has to provide or manufacturer has to manufacture. So this many number of units if he produce or manufacture per day, then his profit will be maximized. So here's the maximum profit is p into here maximum profit is function is p of x is equal to minus 2x square plus 1000x minus 5000. In that, if you keep 250 in that function, then p of 250 on evaluation you will get $75,000. This is the maximum profit. Okay, so maximum profit function he defined, and what is the optimal production he has to produce, therefore he can attain maximum profit. So most of the companies like Apple, Samsung, Toyota use this concept daily. They use this concept, means approaching derivative concept, and they will optimize their production and map profit. Okay, next, medicine and pharmacology. So in this also, how differentiation help their activities here. Drug concentration in a bloodstream, drug concentration. So this drug concentration function is given by 10 t into e power minus 0.5 t milligrams per liter at t hours. Okay, so this is the concentration of the drug he provided, concentration function. Okay, in the duration of t hours. So when his concentration is maximum, when the concentration is going to be maximum means the concentration function, derivative of concentration function is c dash of t. So which 10t e power minus 5, 0.5t differentiation is going to be 10t into e power minus 0.5t minus 5 into t into e power minus 0.5t. How this happens? See, so 10 into differentiation of c dash of t, differentiation of c dash of t, see 10, this is a constant to keep aside, and t into e power minus 0.t or variables. So you need to, here actually t should not be here, t differentiation is going to be 1, so t should not be 10. So 10 into t differentiation 1 e power minus 0.5t plus, and where t and e power minus 0.5t, we have two functions, so we need to apply uv rule, differentiation of uv rule. So 10 into u is u differentiation 1, means t differentiation 1, and I'm writing e power 0.5 e power minus 0.5t as it is. Next you write t as it is, and e power minus 0.5t differentiation is going to be minus 0.5 into e power minus 0.5t. So when you multiply by 10, this gives us 10 into e power minus 0.5t minus this 10 into minus 0.5 is there na, that going to be minus 5 into t into e power minus 0.5t. So this is the derivative, which is which is equal to 0, that implies t equals to 2, t equals to 2. So after 2 hours, in the period of 2 hours, the concentration of the drug is maximum. Okay, so when the dosage of drug is provided into the body, in duration of 2 hours, the maximum concentration will be applied, the maximum concentration will be taken place. Okay, so peak effect time is 2 hours after dose. This is what provided here. So real use, determining dosage intervals, means of use to say that when we approach the doctor, he provide the medicine and suggest and he will suggest us take the medicine like this in the morning, after 6 hours one dose you take, like that. They used to say that dosage intervals will be defined based on the disease and the patient condition. Antibiotic effectiveness timings, these also defined, antibiotic effectiveness timings, and anesthesia monitoring also will be taken, monitoring also taken by the concept of derivative. So here determining dose intervals, antibiotic effective timings, anesthesia monitoring, all these means all these things are planned under the concept of differentiation. Next application, that is engineering, minimizing materials, means, so when designing a cylinder soda, so where the volume of a cylinder soda is 500 ml volume, using least material, we have to accommodate this much volume. Okay, so it's a cylinder na, so cylinder volume formula is pi r square h, so is provided by 500 ml. So from this h I made h subject, so h is equal to 500 by pi r square. So what is the surface area from this? So including top and bottom, so 2 pi r square plus pi r h. Pi r h is about curved surface area, and part pi r square, top pi r square, and bottom also pi r square. So we have 2 pi r squares, that gives 2 pi r square plus surface area, means curved surface area is 2 pi r square plus. So in this h we have as 500 by pi r square, that we are subject here, we are substituting that 500 by pi r square. So on putting 500 by pi r square, it is going to be 1000 by r. So 2 pi r square plus 1000 by r. So now derivative of s dash of r is going to be 4 pi r minus 2 pi r square, here 2 pi r square 2 pi r square plus pi r into h. H is given by 500 by pi r square. So pi get cancelled. So 2 pi r square plus r get cancelled. So 500 by r. This is not 1000 by r. It's by mistake it has happened. So 500 by r. Now, so here SR equals to what to get here? 2 pi r square plus 500 by r. Now whose derivative is going to be s dash of r is equals to 2 pi r square. By r square differentiation is 2r. 2r into 2 pi is going to be 4 pi r. 500 by r means minus 500 by r square. Minus 500 by r square. Now this equal to 0. This equals to 0. Then what you get? 4 pi r cube is equal to 500. R cube is equals to 500 by 4 pi. Then r equals to cube root of 500 by 4 pi. So this we need to evaluate using calculator. Okay. So means the prescribed volume can be hold in a cylinder with the least usage of material. With the least usage of material. That concept also we apply using derivative concept, using the tools of derivatives. Next, architecture and bridge design. Suspension bridge cable shape. So this is the parabola curve. Y is equal to wx square by 2t. This is the function for suspensible bridge cable shape, and whose derivative is x square differentiation is 2x. W into 2x by 2t is going to be wx by t. This is derivative, means the slope at a point will give. It says slope at point will give. Okay, so suspension bridges can be constructed under the concept of derivative. Derivative help us to evaluate the slopes, perfect slopes. Means we plan to evaluate the slopes and all, so that the suspension bridge will sustain long time. So engineer used to use this to calculate cable tension at each support. So they have given it. So this is the suspension bridge. I have given the picture here. So there cables are tied. So the tension of the cables will be calculated, so that the suspension bridge handles means balanced equally. Determine lower height requirements and design safe load distribution. Okay, so these are the things will be taken into consideration for constructing a cable bridges or suspension bridges. These factors are evaluated or taken or look after by the derivative tools. So suspension bridges like Golden Gate Bridge, Brooklyn Bridge, these are the examples. Suspension bridges. These bridges are built using the concept of derivatives. So population growth. Bacteria population in lab, they have given population function by 1000 into e power 0.3t in hours, t hours. Whose growth rate, what is the population growth rate means? You do differentiation of population function, that is p dash of t. So that is p dash of t is equal to 300 to e power 0.3t. How this 300 comes means here, actually p of t is what? P of t is equals to 1000 into e power 0.3t, 1000 into. So p dash of t, so 1000 is a constant, you will keep aside, and e power 0.3t differentiation is 0.3 into e power 0.3t. So multiplication of 1000 into 0.3t is going to be 300 is going to be 300. That is what P dash of t equals to 300 into E power t, which is approximately equals to 1344 bacteria per hour. This is the growth rate per hour. This number of bacteria is releasing. So this way, the population growth of any bacteria can be evaluated. So real use predicting epidemic spread, how the bacteria rapidly spread, that we can evaluate. That is what we we plan to take the precautions, conservation planning, and food spoilage estimation. These factors can be planned, or these factors can be uh, planned under the use of under the applications, under the use of derivative concept. Next, temperature change in a day. Nowadays the day temperature, how the change in morning, and afternoon and evening times, how the temperatures are changing. That function is built by 25 plus 10 into sine of pi by 12 of t minus 6. This is in t hours, after t hours means from midnight to evening. So rate of temperature means the differentiation of the temperature he evaluated. So 25 differentiation is 0. 10 into sine pi by 12 t minus 6 differentiation is pi 12 into cos of pi by 12 into time t minus 6. So this is a rate of change, the rate of change of temperature in the day. So at 9 hours, at morning 9 o'clock, what is the temperature, what is the change of temperature? If you want, you can evaluate by putting t by 9 in the rate of change of a temperature function. So that is giving by minus 2.18. So that is maybe warming or cooling. It represents the scenario, means it represents the atmosphere. It takes the temperature takes with respect to the atmosphere presenting inner surrounding. Heat wave warnings, where we use means heat wave warnings, how the, so in summer, during summer days, uh, forecast, weather forecasting people give a caution to the public. So today we have heat waves, strong heat waves, take precautionary things, don't move outsides, like that they used to give some precautions. Now that will be evaluated, these heat wave things will be evaluated using concept of derivative. And agricultural planning, HVAC system design. HVAC system designing means home ventilation and air system, air and air and cooling systems. Okay, so this this HVAC system design also done under the, so this is what HVAC system, these two pictures shows about HVAC system design. This HVAC system design taken place by sinusoidal function. This sinusoidal function gives a structure of HVAC system, how we design. Okay. Next, traffic flow and transportation. So this is the in a very heavy flows junctions, like very heavy traffic junctions, we need to clear the traffic as early as possible. In such cases, this concept of derivative is useful. So this is the traffic junction, this is the traffic function defined, where number of vehicles are passing, so whose derivative function is defined. And if I define equal to, if the derivative function, if I make to 0, then we define the value v. So 5 kilometers per hour means we need to maintain 5 kilometers per hour at a traffic junction, so that the traffic will be cleared as early as possible. And correct optimal speed of our for our highways, 80 kilometers per hour. Okay, for highways 80 kilometers, at traffic junctions, so 5 kilometers per hour they have to maintain, so that the passing of the cars or vehicles smoothly runs and traffics will be cleared in a time. So this is one. Next, sports and sciences. In basketball free throw, to reach the basketball into correct position, okay, when we throw a ball from a distance and has to reach the ball to the basket exactly, So that plan of action is taken by the concept of derivative. Basketball throw arc function is given by like this: y equals to minus 0.02 x square plus 0.8 x plus 2. Okay, and the derivative of this function is this, and x is equal to 20 feet. Here x is the distance he has to stand. Okay, so find the peak height of the shot at x feet. Sorry, here x is height of uh, the throw. When you throw a ball, the maximum height it reaches to. So peak height will be maximum distance he has to stand, and peak height will be 10 feet. So when he is stand at a 20 feet away from the basket, okay, and if he throw and reaches to peak height to 20 feet, and it reaches to the correctly, it reaches to the basket correctly. Next, so this help us correct shooting arc and designing training drills, analyze player performance. These factors will be studied well by the concepts of derivatives. Next, artificial intelligence and machine learning. In these also, derivative concepts are very much are using. Okay, minimizing error using derivatives in AI learning, and gradient descents. Okay, w nu equals to w old minus eta into e dash of w. E dash of w is nothing but error derivative, and eta is error factor function, and this is the value, correct value and old values, new values and old values. Okay, in the old values, these are the errors we are deducting. Okay, we are removing, so that we get the new values. So behind, to evaluate correct values using approximate values, we have to deduct the error. That errors will be evaluated using the derivatives. Okay, and applications: self-driving cars, uh, and voice assistants like Siri and Alexa are the tools which help us voice questions. If you ask the questions, it provides answers. No, okay, voicemail questions. Tools are there in Siri, Alexa. So these also works under the concepts of derivative. Movie recommendations, Netflix, Amazon, and all movie recommendations will also useful. Means movie recommendations are one will works on derivative. Free recognition and 3D surface with gradient arrows pointing downhill. These are all so these 3D images I provided here. This 3D images shows exact pointing downhill, where slopes happen, where down is where the decreasing, where it is peak. That will be evaluated using the concepts of derivatives. Now, practicing one problem I practice here. So here, so what is given? A farmer has 240 meters of fencing to create a rectangular field along a river. So this is the river. This is the river. So here, beside the river, he has a field. He has to prepare a fencing, a rectangular field. Rectangular field. Okay. So for this rectangular field, he has fenced. He has fenced here. So with the breadth as x meters, x, and length by y. Okay. So this is the field beside the river, and one side is river, and the remaining three sides he given a fencing to this field. It's a rectangular field. Okay, this is a rectangular field. Now length, let us take breadth by x and length by y. So then fencing. So fencing is given 3 sides, so 2 breadths plus 1 length. How much meters of fencing he has taken here? 240 meters. So from this, y equals to 240 minus 2x. 240 minus 2x. Now, what is the maximum area he has to? First, what is the maximum area? To maintain maximum area, what are the dimensions of the field he has to take? So for that, you define area. Area means length into breadth. So here length is x and breadth is y. Y is defined in terms of x by 240 into minus 2x. That is 240 minus 2x. So when I multiply, this is going to be 240 x minus 2x square. This is area function. To maximize the area, find the maximum to find the dimensions to maximize the area, you need to take the derivative of the area of the function. That is 240x differentiation is 240 minus 2x square differentiation is 4x. X square differentiation is 2x. 2x into 2 is 4. And make equal to 0. First derivative equal to 0. Then you will get the x values at which area will get maximum. A dash of x is equal to 0. Then x is equals to 240 by 4 is going to be 60 meters. Y is equal to 60 meters. Therefore, x is equal to 60 meters. Therefore, y equals to 240 minus 2x. 2x means 20, 60. So, which is equals to 240 minus 120, which is equals to 120 meters. Y equals to 120 meters. So, with the 240 meters fencing of a rectangular field, he has to maintain the dimensions of 60 meters breadth and 20 meters of length. Then it attains maximum area. Okay. So likewise here, to define the dimensions of the rectangular field to cover the maximum area, we apply the concept of derivative. Okay. So likewise, so many real life scenarios can be handled by the concept of derivative. Okay. So this is what defines calculus of differentiation calculus. And final quote is, calculus is the mathematics of change. Understand derivatives and you understand how the world moves. This is the final quote. Okay, that's all. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.